Okay, no issue. So I am starting now. So hi, I am Anuj Kumar, working as a Prime Minister Research Fellow in IIT Roorkee, and this is the second assignment of the NPTEL course, Colloids and Surfaces. So I will be discussing some questions on the basis of the units you have read in the second week. Okay, and this is the first question. This is a very basic question. So consider two spherical particles of radius r. It is given a 1 nanometer, and the second one is the 1000 nanometer. So you have to assume that other physico-chemical properties of the particle will be identical. So you have to just calculate the ratio of surface area of the smaller particles, that is having radius equal to 1 nanometer, to the larger particles, that is having radius to 1000 nanometer. Okay, so this is a very basic question. You have to just expand the formulas. You can try it by yourself. I will wait for 2 minutes, and after that I will solve it. Okay, so this is a question. So what is given here? Okay. So one spherical particle is having a radius 1 nanometer, and second is 1000 nanometer. Okay, so you have to just calculate the ratio of smaller particles to the larger particles. So you just need to expand the formula for area of the spherical particle, that is 4 pi r1 square, 4 pi r2 square. Sorry, 4 pi r1 and r2 square. Okay, so these will be the cancel out terms, and square 1 into 1000, that is 1 10 to power minus plus 6, and you can write it 10 to power minus 6. Okay, so the correct option will be the third one. Okay, if you have any doubt in it, please mention in the chat box. Yes, Seema, if you have any doubt, please type in the chat box. Otherwise I will go to the next question. Okay, not issue. Second is the, you have to find the ratio of specific surface area of smaller particles to that of the larger particles. Okay, so you are already given the values of r1 is 1 nanometer, r2 is 100 nanometer, 1000 nanometer, sorry. So specific surface area is equal to area per unit mass, per unit mass. Okay, it may be kgs, grams, or depending on the unit. Okay, so okay, so the specific, if I denote it as specific surface area. Okay, so for the smaller particle it will be SSA1, and for larger particle it will be SSA2. Okay, so A1 divided by M1, and A2 divided by M2. Okay, so that will be A1 into M2, and A2 is equal to M1. Okay, So you have density values are same. Okay, your density values are same. So mass equal to density equal to mass upon volume. Okay, and the mass equal to density into volume. So you have to just expand it. A1 by A2, M2 is equal to rho 2 into V2 divided by rho 1 V1. Okay, so these terms will be cancelled out. I am writing again here. So A1 by A2, V2 by V1. Okay, so this will be 4 pi R1 square, 4 pi R2 square, and V2 is equal to 4 uh, pi by 3 pi R2 cube. Sorry, this is capital R, and similarly 4 3 pi R1 cube. Okay, so these terms will be cancelled out. Okay, that will be R1 square into R2 cube divided by R2 square into R1 cube. Okay, so R is 1 nanometer, 1 square. R2 is 1000 whole cube divided by R2 is 1000 into 1 whole cube. That is 10 raised to 6 3. That is 10 raised to power 3. That will be the right answer. So third option will be the correct one. Okay. So it is okay with you. Please try to respond. Okay. Okay. This is the right option for this. The third question it is from the dynamic light scattering technique. So you what is given here? Just diffusion coefficient. Okay. So D equal to 2.88 10 raised to minus 11 meter square per second, and your temperature value is 293 Kelvin, and uh, your viscosity is given 0.001 kg per meter. Okay, so you have to just calculate the radius of the particles. The Boltzmann constant is given here for your reference. It's 1.38 10 raised to minus 23 joule per Kelvin. So you have to just report the value of radius in nanometer. And for hint, I have given here the formula. You have to just put the values. So kb is it, it just like this. Okay, so you have to just put the values and note the units. Okay, so try by yourself. Otherwise, after 1 or 2 minutes, I will solve it. just want to see this here. Imagining David Matthew. Okay, please try to respond. Okay, you have to calculate the values. Simply put up. That is, formula is T is equal to KBT is equal to 6 pi mu r, where r is the radius of the particles, mu is the viscosity, and T is the temperature in Kelvin. Okay, so that is the Boltzmann constant. Okay, so D value is given here. So R equal to KBT 6 pi mu to D. Okay, so KB value 1.38 10 to power minus 23, and your value of temperature is 293. 293. Okay, and 6 3.14 and 0.001. Okay, someone is trying to. Okay, 0.001, that is the value of viscosity given in your examples, and the value of diffusion coefficient is 2.88 10 to power minus 11. So sorry, so you just also note the units. Okay, uh, for Boltzmann constant, it is Joule per Kelvin. Okay, and into Kelvin is for temperature, and for viscosity is kilogram meter second. Okay, and multiply by D, and the unit of D is also given here, meter square per second. Okay, so I will solve the units conversion later on, or anyway I can solve in side by side also. Okay, you just calculate this value in your calculators. That is 1.38293, 404, 404 minus 34 10 to power minus 23, and the denominator part will be into 0.001, 2.88, that will be 0.0542. Okay, and 10 to minus 11. Okay, that will be 7460 minus 23 plus 11. Okay, 7460 minus 12, or 7.460 10 to power minus 9. Okay, so if I solve the units, it will cancel out. So you have to just expand joule. Joule equal to kilogram meter per second square into meter, simply using the work formula. Okay, so just put these values: meter square per second square, kilogram meter square. Okay, and second square. Okay, and 1 meter also, this one. Okay, so these terms will be cancel out, this will also cancel out, it will be meter. Okay, so you can write here this, because you know 1 nanometer is 10 to power 9 meter. Okay, so the correct option, okay, there is no option, so this will be the value of the radius of the particle. You can solve the similar questions on the basis of this formula. Okay, if you have any doubt with this question, uh, please type in the chat box. Otherwise, I will go to the next question. Seema and Benjamin, if you have any question, please type in the chat box. If there is no question, please type. I'll go for the next question. Okay, it is a simple thing, and okay, I am just going to the next question. Uh, okay, this is a basically theoretical question. So you have to just match the column A to B, and the expressions for the each of the forces are provided here in the column B. You have to just match. Okay. During theory sessions, you have uh, already studied about the Brownian force, hydrodynamic force, gravitational force. But here is just you have to match the formula. Okay. These are three options you have to select. Okay. So there is no calculation in this question, so please type in the chat box for the response. Just try to match. Okay, after that I will tell you. These are simple formulas. Kbt is thermal energy. You have to just see which force is generated by the thermal energy, that is kbt. A is the radius of the particle. Okay, I'm not getting any response. At least you can try. Okay, this is the interactive session. Okay then. So Brownian force is you can directly match. Okay, I will do the full wave. Yes, you can match this one. Hydrodynamic force is generated by the viscosity, and the viscosity factor is only here. So on the basis of these basic understanding, you can match the columns. Gravitational force is, you know, gravitational force is just equal to mg. F is equal to mg. M is density into volume. Okay, particles, volume of particles. Okay, so this is the density difference between the dispersion medium and the particles. So on the basis of that formula, you can also match this gravitational force and osmotic pressure. This one is the correct match. So first is the fourth, and B first. C is matching to second, and D is matching to third. So this will be the correct option for it. This is a basic formula based question. Okay, so this is the next question. Uh, this is one scientist, post Pisil, observed the motion of soot particles of having radius equal to zero point 0.4 into 10 to the power minus 4 centimeter. Okay, in a water glycerin solutions with the mu that is zero point 0 twice and T 292 Kelvin. The observed value of mean square displacement. Okay, so mean square displacement value is given here 3.3 10 to raised to minus 8. For you also given the time. So use this information to calculate the Kb values and hence the Na, that Avogadro number. Okay. So this is also a formula based question. You have to just try it and send me the response if you can. I'll wait for 2 to 3 minutes. After that, I will solve it. Okay. Although I'm not getting any response, please try to solve the questions. Okay. Otherwise, I will go for the solution part. Everything is given here. The radius of the particle are also given. You have to just keep the units in mind. Okay. Centimeter, twice. So you can first solve all the numerical in the CGS system, and then you can convert accordingly to SI system. Okay, so here is no any limitation of units, so you can just calculate your answer in any of the units, whether it is MKS, CGS, or SI. Anyone is trying to solve? Okay, okay, Benjamin, uh, try and get the answer, and after that I will give you the solution for this. You have to just apply the Einstein equation for this. Okay, so I am going to the solution part of this question now. Okay, so you know, this is the equation of Einstein, that is the root mean square, sorry, mean square velocity, that is kbt 3 pi eta r. You can say this tau as t, total time. Okay, so from this formula, okay, you can rearrange. You will get kb and 3 pi eta r divided by temperature and the time and this. So you have all values given in the numerical. Okay, for example, the 0.0728 poise. Okay, 3 pi is put as such. You can expand into 3 into 3.14. Okay, and after that you have a radius in centimeter, zero point 0.4 in 10 raised to power minus 4 centimeters. And for mst, that is mean square displacement, you have given is 3.3 raised to minus 8. Okay, and for temperature value is given 292, and for time the experiment is done, the values of msd is collected for 10 seconds. So you have to just put the values 10 seconds and you will got 1.1 or 10 to power minus 16 erg per kelvin. That is the unit of Boltzmann constant in cgs system. Otherwise it was in mks, it was joule per kelvin. Okay, so again using these results we have kb is equal to just r upon na. From this you have this value you can calculate the avogadro number. So this is the value of avogadro number after these simple calculations. So the solution is clear. Later on I will go for this formula also. Okay, in general d is equal to kbt by 6 pi eta r naught, or you can say r. Okay, so I am going to next question because we have time limitations. Okay, so that is another question. So a Brownian particle of radius, this is the radius 10 to power minus 7 meter, and temperature is given 20 plus, you have to just convert into Kelvin. Okay, if the value of RMS displacement, root mean square, okay, this value is given here 6.5 10 to power minus 6 meter, and the data is collected for 32 seconds. Okay, calculate the value of Boltzmann constant. You have to calculate Boltzmann constant value, and viscosity is given here 1.2 10 to power minus meters per meter square. Okay, you have to just apply the same formula, but uh, you will have to square this value, because in the formula there is mean square displacement value. There is no root mean square displacement value. Okay, so you have to just square this value and put up in the formula. Okay, like this. Okay, so this is the formula, and we are given the RMS displacement this value. Eta we are also given, R naught value is also given. To use the value of RMS displacement in above formula, we have to calculate it is square to remove the under root value. So we can write here the square is equal to kb, temperature value 293, and the time is 32 seconds. So 3 into pi is equal to 22 by 7. So this 7 is above, and eta is, that is 1.2 10 to power minus 3 Newton second per meter square, and for R value is given here 2.1 into 10 to power minus 7 meter. So solving this calculation and the units, you will got this value in joule per Kelvin. Okay, so that is very close to the reference value, that is 1.38 10 to power minus 3 joule per Kelvin. Okay, so after every question I am asking, if there is any doubt, kindly tell me. Okay, otherwise, if there is no doubt, kindly do type yes. Okay, or if you have any doubt, kindly type in the chat box. Okay, I am going to the next parts. So this is the Brownian experiment is conducted with an intention to measure the Avogadro number. So the intention of the experiment was to just measure the Avogadro number. The experiment involved video microscopy, wherein the camera just attached to it, and it is used to visualize the Brownian motion. Okay, and the mean and the what is recorded, that is recorded the mean square displacement as a function of time. Okay, so we got these three straight lines for different diameters of particles. One diameters, particles are having zero point 0.5 micron, others are having 1.09 micron, and third one is having 2.606 micron. Okay, so again, these values are given to us. Okay, so uh, the slope of every line is provided here in the question. Okay, so the first line have the larger slope value, and the second and the third. Okay, okay, this is okay with the graph. And first is the calculate the Avogadro number from the data corresponding to the particle of size zero point 0.5 micron. Okay, so from the equation, the average mean square velocity is equal to 2 2 dt. Okay, if you have uh, if I arrange it, the formula, that is x square by 2t is equal to d, and I expand it, kbt is equal to, okay, 6 pi mu r. Okay, so these values are cancel out. X bar by t is equal to kbt 3 pi mu r. Okay, so I am arranging in it, the x bar square equal to kbt 3 pi mu r t. Okay, if I plot a curve of uh, mean mean square distance versus time, I will get a straight line like this, and this value will be of the slope. Okay, and the slopes are provided here. So uh, slopes are provided here. I am just solving. Okay, so the kbt, first I am solving for the this one, kbt 3 pi mu r 12.3 10 raised to minus 30. Okay, Expand the kb, that is rt divided by 3 pi, okay, na into mu r 12.3 10 raised to minus 13. Okay, so value of r 8.3 joule per kelvin per mole. Okay, and temperature you have to just in this particular question you have to just uh, take the value of temperature is ambient temperature, that is you can also write to 250 degree or 270 degree to 27 degree. Okay, or you can say 25 degree, that is the ambient temperature, or you convert into the kelvin, you will get this value. Okay, and the mu value is as default, that is that was also provided in the last question, that is the same value. Okay, 0.001, 0.001 kilogram per meter second. So you have this value, this value, this value, and this value. But before putting in the formula, you have to convert it. R is equal to zero point 0.5 into 10 raised to minus 6. Okay, from this value you can calculate the Avogadro number. So the Avogadro number will be RT divided by 3 pi, okay, into mu R 12.3 10 raised to minus 13. Okay, I'm writing here. So Na will be equal to 8.31 into 300 Kelvin, okay, and 3 into 3.14 0.001, and uh, next is the radius, that is zero point 0.5 10 raised to minus 6, and 12.3 10 raised to minus 30. Okay, so sorry, so you can just do the simple calculation. After solving, sorry, you will get the value of Na equal to, okay, I'm just calculating it. 8.31 multiplied by 300, that is 2493. Okay, and the denominator part will be 3.14 0.001 0.5, okay, 2.3. that is 0.0108333 and 10 raised to minus 19. Okay, so 2493 divided by 0.0108, that is 2 30833 10 raised to minus 19. Okay, just to verify the calculations. 8.31 300, okay, divide by uh, 3 into 3 3.14 point 001 point 5 2.3. Okay, 2.30833 10 raised to minus 23. Okay, so there is some calculation error. Okay, just try again with yourself. Okay, and in the next sections you have to just calculate for different sizes, that is 1.09 micron, and for the third one, that is I think 2.06 micron. Okay, similarly you have to calculate. Okay, similarly you have to calculate from for different parameters, just like for these are three radius values: zero point 0.5, 1.09 and 2.06. So these are the different slope values. So you just have to put the slope values equal to this value and uh, put the parameters accordingly. That is the Boltzmann. Okay, you have to just expand kb is equal to r divided by na, and for that you have to put the value of r, that is 8.31, multiply by temperature value, that is 300. Okay, and divide by 3, multiply by 3.14, and viscosity value, and again the radius value, but you have to convert it into micron, sorry, micron to meter. zero point 0.5 into 10 raised to minus 6, and after that you have to uh, just rearrange the things, and you just, okay, this is 12.3 here, 12.3. So this is the calculation problem. I'm just again calculating it. Point 0.5, 12.3. Okay, uh, so the denominator term will be, okay, this term will be just like 0.057. Okay, this will be 0.057, 10 is to minus 90. Okay, so now you divide 2493 divided by 0.057, or you will get the right answer for it. Okay, so you just have to select accordingly, and this is a range given here for the values. You can get this this term between these values. Okay, so you have to just accordingly do for different radius values. Okay, till this question, if you have any doubt, kindly ask me in the chat box. Otherwise, I will be ending up here. Okay, but before that, okay, the another problem is here. What is this? Is the value of diameter? You have to convert into radius. Okay, so you have to just put 0.5 by 2. That is 0.25. Okay, so sorry for that. You have to just put the value of radius here, not the diameter. Okay, so 0.25 you have to put here, and after that you will be getting this answer. Okay, so similarly you can solve it for other radius values. Okay, so I am ending the session now. If you have any question, please type in the chat box. Otherwise, I will be leaving the meeting.